series and sigma notation. A series is when the terms of a sequence are added together. Okay, when the terms of a sequence are added together, that's what a series is. So for instance, there's two types of sequences, and there's two types of series. So there is something we call a finite sequence. And a finite sequence would look like this: 3, 7, 11, 15, and 19. So finite just means that it ends. A finite series is where these are added together. So 3 plus 7 plus 11 plus 15 plus 19. So that's a finite series. We're adding them together. I'm going to give you a bunch of definitions right now. There's something else called an infinite sequence. This is a sequence that doesn't end, it keeps going. So for instance, 1/2, 1/4, 1/8, 1/16, and then you'll see this dot, 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 and there's nothing there. That means that it's going to keep on going, that it doesn't end. With an infinite sequence, there is something called an infinite series. So an infinite series would be 1/2 plus 1/4 plus 1/8 plus 1/16 plus dot, dot, dot. Okay, so that's how you'd write an infinite series. So do you see the difference between a sequence and a series? A sequence is just a pattern of numbers that go along. If it's finite, it ends. A series is where they're added together. It's the sequence that's added together. An infinite sequence, here I just have the numbers like this, or just a sequence of numbers. It doesn't end, it just usually goes dot, dot, dot. That's an infinite sequence. An infinite series is where I have 1/2, 1/4 plus 1/8 plus 1/16, and it's going to be approaching something. Okay, but it's added together, and you'll see dot, 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 and it goes on for infinity. Two more definitions here before we actually do something. An arithmetic series is one that's related to an arithmetic sequence, whereas a geometric series is related to a geometric sequence. Okay, so these are all the ones that we're going to use. Oh, actually I have one more for you. Okay, so all of this and a special one called sigma. It's a Greek letter. It looks like this. Oh, I didn't draw that very good. Can I try again? That's better. Alright, so that's sigma, and this is a summation sign. Okay, a summation sign. Sigma is a summation sign. So it would mean, you know, all these things added together, right? All these things added together. Well, when I see sigma, then I'm going to know that I have a series. I have something that's going to be added together. There are two forms of this sigma, and again, this is another definition. Sorry. Okay, there's two different things they might ask you for. They might ask you for expanded form which is this. Okay, so this is expanded form. Expanded form looks like, I don't know, 2 plus 4 plus 6 plus 8 plus 100, right? There's a bunch of stuff in between there that I don't want to write down. So that's expanded form would look like this, but sigma notation looks like this. Here's my sigma. Here's that formula that you guys were finding yesterday with your arithmetic series, your arithmetic sequences and your geometric sequences. That's that n. You already know how to get that. This n goes from 1, right? If I put 1 in there, I'm going to get 2. And then 2n equals 100, so that's going to give me 50. So n goes from 1 to 50, and I'm going to use the formula 2n. This is sigma notation. Okay, and that's a 50 there. So this means, here's the meaning of it. You're going to sum up 2n, starting at n equals 1, all the way to n equals 50. Sigma notation. So, of course, I'm not going to write that across my page because I probably need a few pages. But it's all these numbers expanded out. Sigma notation, okay, and these are also definitions. Okay, with all of that stuff, we are going to now try some. Alright, let me switch pages really quick here. But now, can you help me? Okay, so series and sigma notation. So we're going to actually do something. And here's some of the stuff you're going to see in the book. So it's going to say write the series in expanded form. Okay, write the series in expanded form. So this is going to be an example of that. when they say write the series in expanded form, that means they are going to give it to you. I'm not really having issues with writing sigma. They're going to give it to you as a sigma form. So n equals 1 to 5. The formula is 3n plus 1. And they want you to write it in expanded form. So what you're going to do is this. You're going to take this n, I'm going to put it in green. Here it is in green. And I'm going to use 1 to 5. So here I go. It's going to look something like this. 3 times 1 plus 1 plus 3 times 2 plus 1. Don't forget PEMDAS in there. Plus 3 times 3 plus 1 plus 3 times 4 plus 1 plus 3 times 5. I'm going to 5 here, right? 5 plus 1. I'm not done. That's not expanded form exactly. Not yet. I'm getting there. I just have to simplify each piece. Okay, so I'm going to simplify each piece. I substituted in 1 all the way from 1 to 5. So each one has to be represented between 1 and 5. What I'm going to get here is 3 times 1 is 3 plus 1. So there's a 4. 3 times 2 is 6 plus 1 is 7. 3 times 3 is 9 plus 1 is 10. 3 times 4 is 12 plus 1 is 13. 3 times 5 is 15 plus 1 is 16. And this is my answer right here. Alright, so as far as what I'm supposed to do is substitute in with 1 through 5. Simplify each term. Okay, and then that's pretty much it. Just simplify each term. That's expanded form. But of course they're not going to want you to just write expanded form. They're going to want you to go from expanded form to sigma notation. So here's an example of going from expanded form to sigma notation. Okay, here's an example where I give you expanded form, and I'm going to need you to go into sigma notation. Now, it's not that bad. It looks kind of scary because you're kind of wondering where the heck that came from, but you already know how to do this. You can do it. You just need to figure out, you know, what kind of series do you have? Is it arithmetic or is it geometric or neither? And then you need to figure out the formula. Remember we were doing that in class yesterday. How do I figure out the formula? That Tn. That's what goes here. It's just that Tn into that sigma notation is Tn. So let's do that. Let's figure this out. So between here is 7, right? That's my difference. 7 is my difference. So I must have an arithmetic series. Remember, the formula for an arithmetic series is Tn equals T1 plus n minus 1. I can't remember what color I used. Oh well. N minus 1 times the difference d. So that's the formula we're going to use. Once we figure this out, this goes in there, right? But we're just going to figure it out for Tn. Okay, easy enough. Think we can do it? T1 equals 7. What else do I need? D, oh, I confused myself all of a sudden. D, the difference is also 7, right? T1 is 7, the difference is 7. And N, I don't know what it's going to, I don't know this, you know, is it going 1 to 5? I don't know. We'll figure it out, and I'll show you how to figure that out in a minute. Alright, so what I'm going to call N then is just N. So I'm going to say N just equals N, and that's what I'm going to put into my equation. So what I have then is Tn equals T1, which is 7, plus N minus 1. Sorry, I shake everything when I pull these caps off. N minus 1 times, let me make sure I get the right D here, times 7. Okay, so that's what we have in the pretty colors. Now I'm going to go not to the pretty colors because it takes me too long. So what I have is Tn equals 7 plus, and I'm going to distribute this. I'm distributing 7n minus 7. Well, this 7 and this 7, if I combine those terms, I'm going to get 0. So Tn is 7n. I have what's going to go into my sigma. I have it. It's 7n. Okay, so now I'm going to do my sigma notation. I'm going to put 7n here. N equals, okay, now what does n equal? You have to use your noggin here. What does n equal? It's going to go from 7n, what would n start at? It starts at 1, right? Because 7n would give me, if I multiply by 1, would give me 7. Well, it's the same thought process over here. 7 times what gives me 700? Oh, it's 100. So it's going to go from 1 to 100. And that is my sigma notation. That is what I'm looking for. Okay? Let's see if I can do some steps here. So you're going to have to find the formula, right, for the specific series. And then all you have to do from there is find your starting n and your finish n. And that's just by setting them equal. 7n equals 700, solve for n. 7n equals 7, solve for n. Okay, and then 3 would be right in sigma notation. Get that up so you can see what I wrote. Alright, pause the video, get the rest of those notes, and we will finish 2 more examples. This one was arithmetic, and we will finish up with a geometric and a neither. Okay, the next one we're going to do is one with neither, and they can be a little bit tricky. So here's an example. And this one's neither, and when you have neither, you need to look for pattern, because you can't use those formulas. Okay, we don't have the formulas that we can use with the geometric and the arithmetic, so we just have to look for a pattern. A lot of times when they give you neither, they give you fractions. They like to freak you out. But the fractions end up being not so bad because you can look at them separately. You can look at the numerator and see if there is some kind of arithmetic series in the numerator or geometric series in the numerator. And you can look at the denominator and you just kind of take them separately. You know, is there an arithmetic series in the denominator with just the denominator numbers, or is there a generic series with the, you know, with a geometric series with the denominator? And then you just put it together in the end. So that's a possibility. And I'm sure that we'll give you some of those for your homework. But here is a series that is neither. Go one more just for fun here. Okay, that's neither. And if you look at it, you should see, like, if I look at the numerator, they're all 1. Okay, well, I'm pretty darn sure then that in my formula, the numerator is going to be 1. Right? Separately from that, okay, so I know, here's my sigma. I know it's going to be 1 over something. I don't know what, but it's 1 over something. And then when I look at the denominator, well, this one, you know, we can give it a leg to stand on. When I look at the denominator, what is that pattern? Do you recognize it? Yeah, it's squared, right? It's n squared. It's 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. So it's n squared. There's my formula. Alright? So look at the numerator separately from the denominator. You have to kind of think in pieces on these. So the top, yeah, it's 1. Okay, I'm going to use 1. On the bottom, oh yeah, it's n squared. So I'm going to put n squared in the bottom. So you kind of split it up in your brain. N then is going to start at 1, right? Because it's 1 squared. And it's going to stop at n squared equals 36, so n must be 6. So I'm going to start at 1, I'm going to end at 6. I have 1 over n squared. There's a pattern. I could also have, let's see, let me look here just for a second. Alright, how about this one? 7/3 plus 14/3 plus 21/3 plus 28/3 plus 35/3. What do you think about that one? How about that one? Okay, well, you're going to think of it in 2 pieces. So I look at this one, I'm looking at it as a fraction, and I see that the denominator is staying 3. So I am going to use something over 3. And then I'm going to take these numbers here, and I'm going to look, is it an arithmetic series? Is it a geometric series? Could it possibly be? Well, look, here's the difference. What's the difference here? Oh, it's 7. And here, oh, 7. And here, 7. And here, 7. Oh, that's an arithmetic series. So I'm going to treat it like an arithmetic series, where I know that T1, and we've done this one in our notes, T1 equals 7. T1 is 7. D, I have trouble with D for some reason, also equals 7. And N just equals N. Okay, so I'm using this arithmetic, this idea of arithmetic series, and I'm going to put it into the equation Tn equals T1 plus n minus 1 times d. So I'm going to stick these things in here. I'll end up with something. Tn equals 7 plus n minus 1 times 7, or Tn equals 7 plus, I'm distributing 7n, this should look familiar to you. The 7's cancel out, I have Tn equals 7n. Well, 7n then is just in the numerator because that's what the numerator is. It's an arithmetic series. N goes from, it starts at 1, right? 7 times 1 is going to give me the 7. And it ends at what? 7 times what gives me 35? Oh, it ends at 5. And there it is in sigma notation. So the strange ones are going to be the neither. So this is an example of neither, right? You really have to look for a pattern. And when they give you a fraction, this is your eyeballs, look for a pattern. When they give you a fraction, make sure you look at the numerator and the denominator separately, because that should help you. All right, and we will do some of those in class, so I'll see you tomorrow.